Hello, so a while ago I uploaded this video where I implemented the U-turn technique, where when you take a U-turn, your character stops and does an animation where he is doing, well, a U-turn animation, and how to implement it in Unreal Engine. So there are a few ways to do that. I know two of them. First is this one, as you can see, and the second is this one. Let me show you. Yeah, this one. As you can see, this technique is a little bit wonky, a little bit snappy, but if your game can take advantage of it, really good. For example, if your game is a sci-fi runner like this project, then what you can do is during the transition where it snaps, you can add some particle effects or something. Then it looks like the character is gaining speed or boosting or something like that. You can be creative with it. So there are two ways. I'll show you both. So first one, this one, let's see how it goes. So firstly, go in your event graph. There you'll find movement input or something related to this. Here, what we need to do is we firstly need to create a vector 2, name it input directions. Okay, then bring it out twice. Once you get it, second time you set it, and both the times you need to split it. Okay, so once you have done that, ignore this rolling thing, branch and the rolling boolean. This is something that my game has right now. So once you have that, for move right and move forward, what we are going to do is we will need two vectors in this, which we will rename as direction x and direction y. Okay, so here x will be our, hold on, yeah, x will be our sideways input like this. This will be our x and this will be our y, and z we currently don't have. So for that, firstly connect it between your this what do you call this event starting thing, and add movement input. Then for forward, we need to directly connect x here because our forward, as you see, is y. So our x will be the current x that we have, so we need to connect it like this. And then for the y, what we need to do is we need to get a clamp. Okay, we need to clamp it. So for that, take a note from here and write clamp. Clamp should be clamp float. Okay, we need this clamp float, and in both the cases do minimum -1 and positive +1, because we need to limit it how far it will go. Okay, so once you have that, in move forward, connect the clamped value to y and the default value to x. Then the in move right, connect the clamp value to, sorry, here connect the clamp value to y, and for the right connect the clamp value to x. Okay, once you have done that, we need to move on to the next steps. The next step is go to event tech. Ignore this soft lock thing. I have this is something related to my soft lock thing, soft lock mechanics, for which I have another tutorial. I'll link it in the description if you are interested. So from event tech, what we'll do is get the input direction again, and then also get a branch. We'll get a branch, and from input direction we'll get it is not equal to, and then connect it to the branch. Here what we are trying to do is we are checking if the character is moving, because we don't want to do this animation and all these calculations if the character is not moving. We really want the character to move. uh, by movement I mean that we are giving it input directions, either left or right or front or backwards, that way, not uh, falling and everything, that not that kind of moving, only input movement. Okay, so once we are moving or not moving, we check that. What we got to do is firstly make two arrows. Okay, make sure they are not in the mesh, they are solely child of your capsule component or your main thing. Okay, one I have named it input direction and colored it, oh sorry, yeah. So we need to create two arrows. One should be input direction arrow and second will name it active forward arrow, and make sure they are child of the capsule component, not the mesh or anything. Okay, solely your main thing, main component, whatever it is, it's child of that. One I have painted it blue and the second one is yellow. I'll do it unhide it from the game. Okay, now they will be visible. So the arrows that we created, what we need to do is firstly get the input arrow and set its world direction, set world direction, rotation, sorry, set world rotation, yeah, set world rotation. Okay, we need to do that 2 times, because if we don't do that twice, okay, once for when we are moving and once for when we are not, so if we don't do that twice, then it won't reset and your whole movement will be effed up. Okay, whole orientation will get ruined. So for that we need it 2 times. So when we are actually not moving, okay, when we are not moving, this is not equal to, so thus false will be not moving. So when we are not moving, input direction arrows forward should be active forward vector and we'll add it to the rotation. Okay, we'll just get this active forward rotation and just place it in like that. Oh. Okay, so this is for the resetting. Now we'll get to the main thing. So firstly what you need to do is get movement direction. So this is a function that we need to create. Sorry, I didn't tell you about it. So yeah, we need to create a function where we'll name it get movement direction. Return node we will have outputs. We'll name it right x and forward y. Okay, this is how you create a new output. If you don't have it, name it anything you want, and here you can change it. And if you want to remove it, you will remove it like this. So what we need to do is get control rotation, get control rotation, then we break it. You can also split it. Okay, then we make a rotator, add in only the z-axis. Then from here we will get right vector and a forward vector, just like this. So once we have both, right vector will go in right x, forward will go in forward y. We'll go back to the event graph. Here in event graph we'll get the get movement direction function and our vector 2D, which was input directions. Okay, so what we'll need to do is from movement direction we get x multiplied by input directions x, and from y vector we multiply the input directions y vector, y value, not the vector. Then we multiply each with 250 I guess this is for the length, I guess. I don't know. Basically, this whole system is from a video that I saw on YouTube. I'll link to that tutorial as well in the description. So after that, we'll get the actor location and we'll generate get unit direction. So get unit direction, yeah, so that this way we will get a direction where uh, where our keys are pressed. So our analog stick or your keys, okay, what direction they are actually giving you. So we'll get that direction by adding all these three up, okay, and for the start we'll put in get actor location, and for the end too we'll add the sum of all three. Then we just connect it to this. It will automatically generate rotation from X vector. Okay. So once you have that, you won't have the animation yet, but you will have these arrows. Okay. And you will see as I move, the blue arrow shows the direction that I'm giving my player. As you can see, the blue arrow gives the direction of my keyboard, okay, and the yellow shows the forward direction of my player. By player I mean the whole character, not the mesh. Okay, so yeah, so right now what we have is the directions. Okay, so now we'll go on to the next part where we will add more code so that we'll know to if we need to turn right or turn left. So this is basically turn in place. All right, so here what we will need to do is get the input direction arrow, which means the blue one. Okay, this one input direction arrow we get, and then get relative rotation, not transformation but rotation. Get it, split it. Do this twice because left and right. Then once we have input direction arrows relative rotation, we will need actor forward arrow, this yellow one, its relative rotation. What we will do is subtract the z axis from each one with one another. That way we will get the difference between them, which will show us how big of an angle it is. So basically, as you can see, it creates an angle, right? So that's what we are calculating. So once we get the angle, we are checking if it is less than or greater than. This is basically, well, this, a protractor. So right now I am taking it from 165 to 180, okay, but you can choose to do 170 or 175 or 150, whatever your game feels like. So if it is less than negative 165, we'll go right, and if it's positive greater than 165, then we'll go left. So firstly we'll check for right one. Okay, from here get an execution pin, put it in a branch. Okay, as you can see what I have done here. All right, then we'll need to make two booleans. Okay, one we will name turn right and second we will name turn left. Also we'll create a macro. Okay, in this macro all we have to do is, sorry, that was my phone. In this macro all we have to do is create an input and an output. And the input, I guess you don't directly have an execution pin, so click here, go, type in any name, and here you can have this execution pin. As you can see, this is the execution pin. Click it, you will create it. So we'll need an execution pin, a boolean for turn right, a boolean for turn left. Then set those turn right and turn left and assign it accordingly, then put it into the out, compile, go back into the event graph, and here for the right one we will add do once. Sorry, that was my phone again. We will add do once, and in do once we will add this macro turn right. Here we will check turn right is true. Once the macro is done executing, we will reset this do once. Ignore this, this is just print string that is I was using for debugging. So turn right, we'll need to put turn left as false. Okay, and if this is not less than -165 or whatever your number is, okay, turn right will be false, and then we'll skip to turn left. Okay, so here this is exactly the copy of the turn right one. Just wherever you have turn right, you'll add turn left. Here you will check turn left and uncheck turn right. Okay, so this way right now you will have the code, okay, but not the animation. So now, sorry, bear with me, this tutorial will be a little bit longer. So now when you go into the animations, your what do you call it, AnimBP blueprint, animation blueprint, okay, import in your animations the turn left and turn right animations. Now important note for your animations, they need to be like this. As you can see, he is turning, but he is actually not turning. He is looking in one single direction. Okay, for that, how do I show you? I guess I have those. Yeah, as you can see in this animation, the character is actually turning, right? But you don't need that. You don't need the animations where he is actually rotating and looking the other way. You need an animation where the character is doing that animation but isn't actually turning. If your animation is like the one I showed you before, what you can do is, what I have done, you need to edit the animation. What I've done here is go into root and I guess rotation, the red one. Yeah, in the rotation, as you can see in skeleton tree, the root bone, I have modified it. I have added some keys, keyframes. So in the first one it is 000 as usual, but in the last frame it is -180. Actually it should be 180, but there was some error when I was adding 180. It was going below in the negatives, so I added 190, 179, and it shows 178.99. so just add in 180 or 179, whatever works in your game or for your animation. Okay, that. Another thing for the animation you need to keep in mind is, if your animation is a little bit longer, or if it doesn't blend correctly with your other animations, you will have some jitters, or your animation will play, then your character will do a 360 again and then go forward. That can happen too. I'll demonstrate. So make sure your blend is correct. Maybe you'll need to cut a few frames or add a few frames. Okay, so make sure your animations blend in correctly. Later on I'll show you what the error is actually, but right now add in your turn right and turn left animations, connect it. So once you have connected them, we go into idle to the turns. From idle to turn, what we need is, if the speed is greater than 100, greater than whatever you desire, and then and turn right. Okay, now turn right and turn left, these are basically the ones we created here. Turn right, turn left. So in the event begin, you need to cast to your character and then promote it to a variable. I have named it player. And before you set turn left and turn right, make sure to add is valid. this node, or else you'll get an error. I'll show you what the error will be. Ah, shit. Yeah, you'll get this error. So to avoid that error, just add is valid, and after that, from player we will get that turn left and turn right. From the player, you just drag and write turn left. Yeah, if you can't see this turn left and turn right, okay, if those are not suggested when you write turn left and turn right, go back into this and make sure these are public. Oh, even if they are not public, you can access it. Sometimes it happens that you can't see it or something, but yeah, if that happens, do that. So promote this to another variable which will be in the animation blueprint, not the character blueprint. Okay, so let's say turn left question mark anim. Okay, that way you know which one is which. Okay, so here in your anim graph, between the transitions, get your speed greater than whatever you want, and your turn right and turn left anims connected for idle to the turn. Do the same for the left one. As you can see, I have it same here, turn left. All right, and to go back, just add this time remaining non-combat is equal to 0. Okay, I'm not using time remaining ratio. I'm not using this one, because I don't quite know the difference between these two. But if you know and you think this one will be better than this one for your game, go ahead. But this works fine for me. So once this shows that our animation is complete, turning animation, and we are ready to blend in. So this and turn right is not, which means turn right is false. Okay, turn right is false. We transition back to our idle. Do the same here. If the animation is complete and turn left is false, we enter the animation. All right, so we have our animation set here, and from here we are setting our turn right and turn left false accordingly. Correct? So I guess once you have implemented this, I guess you are good to go. Let me cross check again. Yeah, blend is nice. Correct. Here I have set the blend mode to linear instead of Hermite cubic. Okay, this is personal preference. You can change it however you want. So I guess once you have this, you are feel free to check if your character animation is working or not. Okay, now I'll show you the problem I was talking about. First I'll hide this, hide these, go back. Yeah, now in turn left, which animation do I have here? No. Okay, the one I have is no rot. Turn right 180 right. Yeah, turn right 180 right. Okay, so yeah, let's say I have this right now. You'll see there will be a problem. Okay, I didn't see it. Okay, it is not showing right now, but usually that particular animation gives me a particular problem where my character turns and then does a 360 and then turns back again. so it is not giving me any problem. Well, that is good. So yeah, but you can have that problem. Be mindful of that. Let's check again. Can I demonstrate that problem to you again, guys? Yeah, so it is not happening. Anyways, there are a few things to keep in mind. Firstly, as you can see, this character has some type of clothing and cape kind of thing. Okay, so when you have that, your transition from turning to smooth running, okay, those transitions will be affected. Okay, will not be affected, I mean the imperfections in those transitions will come out more. Okay, as you can see, sometimes you can see where the blend or the transition happens. Okay, also your speed, the speed of your character, the blending, blend times and everything, those matter. Okay, if I change the character, let's say I right now use the normal mannequin. Which one is it? Yeah, let's say I use this mannequin. Okay, the change, you don't see those errors perfectly now. Okay, as compared to the cape, you can see those errors. But again, if your blend is perfect, that cape can cape and that clothing can really enhance it. Okay, so yeah, this was the first technique that I know of. If I've missed something in this technique, let me know in the comments below. Okay, I'll try to fix them and tell you in the comments where what I've done wrong or what I've missed. But I guess I've uh, covered everything for this technique. Yeah, turn left and right. There anything? Yeah. Also, remember to check loop animation off. Remember to check that off. Yeah, and this, you know, that rotation thing, how your animation should look. Okay, let's go on to the next one. Next one is basically I'm doing the same thing, calculating all this, getting the input direction. Okay, and then going into tech. Where is tech? Where is tech? I guess there is the tech. Yeah, no, where is tech? Event tech. Tech. There should be tech. Sorry for this mess. Tech. Yeah, in event tech. In event tech, all these calculations, and then again, as you can see here, I am checking for when we are having input direction. Uh, we are having input directions where it is 180 degrees. Okay, and once it is 180 degrees, I have created an event named 180 run turn. Here, as you can see, I'm basically doing the same thing, getting the input directions, calculating if they are not zero, which means we are giving some directions. If they are zero, then set input direction to actor forward vector. Here I'm not using those arrows. Okay, if you don't want to use that arrows, this is the way to go. But if you want to use those arrows, do that. I would say use those arrows because it gives you some visuals to work with. Okay, actual directions you can see and debug, easy to debug. This is not like this is a bit difficult to debug. So I'm getting the input direction. Here I have created one new vector. It's a vector 3D named input direction as well, just dir, and then connected it, and yeah, you can see. So in 180-degree turn, 180 turn, what I've done is I have parkour in this game, so I've checked everything, that if it is doing parkour or not, or everything in that. So if it's not doing any parkour and stuff, so what I've done is distance from vector forward to a desired vector, which is the rotation that we are doing. Here I have debug. Oh, shit, where it is? Where is it? Tick. Yeah, here. Here I'll show you. Yeah, now you can see the arrow. There will be an arrow. Where arrow? There is no arrow. Yeah, there is a small arrow. The arrow is small. I need to turn up its size. And let's make it yellow. Oh. Thickness size should be, thickness should be 2. Guess you will be able to see it now. Okay, there is some problem with the arrow. Can you see now? Okay, there is some problem with the arrow, but at least you can see the direction that I'm giving. All right. 180. Sorry, I'm taking a lot of time. So once we have the directions, okay, actor forward and the distance, this is basically again this protractor thing. Here I've entered the value 1.7. Play along with it and see what feels good for your game. Okay, if it is true, go forward, get into do once. Here I've added this stop movement and everything, stop parkour, because I have all those parkour things. Then what I've done is I've created a montage. Okay, so that's what I do. I play a montage and then set the actor's rotation to its opposite rotation. Okay, once the montage is complete. This is a bit dumb way of doing it, but if it gets the work done, then hey, it gets the work done. So this is the montage I have, which is basically, yeah, basically turning. So once I turn and the rotation is done, then I go back into reset. So yeah, the first is where we add it inside the animation blueprint, and the second method is to just use a montage. If you can blend the montage easily, then this is nice. Secondly, if you find a way where you can use the montage's rotation, then this is a very good way of doing it. It actually gives you a very good feedback and 0 foot sliding. Okay, as you can see in the other one, we have foot sliding, but in the montage one, you won't have any foot sliding. Let me show you. There is no foot sliding, but in the other one, there is foot sliding. So somehow, if you find a way where you can use the montage's rotation to rotate the character, as we do, we use the montage's location to move the character as well. Transform location, so that if you can find a way where you can use the montage's transform rotation to rotate the character, then please let me know. It will be the best way to implement this, but till then this is the only way I can think of. Okay, and it all this thing, this montage one also depends on your rotation rate. If your rotation rate is really low, this will give you some errors. Okay, if I do this like 100 or something, I guess then it gives you errors, or if it is created. Yeah, you see the snap is more more vivid now. Not vivid, like more noticeable right now. The snap is more noticeable, whereas in 360 it is not that noticeable. But yeah, these things will matter a bit. So yeah, so note that, be careful about it. And yeah, mostly you will have to tweak a few numbers to get the desired result. And again, if you're using this one, make sure your animations are nice and perfect, because there will be foot sliding, and there will be a bit of wonkiness if you have the wrong animations. I really want to get in that wrong animation that will tell you the problem. It happens when I turn left, not when I turn right. And usually the character turns to right rather than left. Okay, so right now it is really not showing me any problem. But yeah, you might face it. So yeah, that's the tutorial. Sorry if it is a bit long. How long is it? I guess, okay, it's 37 to 40 minutes. Sorry if it is a bit long, but I really wanted to get in every last detail that you might need, and everything that you might face, every single minute problem that you might face. I wanted to address that. I hope I have. And if I haven't, if you are still getting errors or having some problems, let me know in the comments below. I will try my best to answer it. And if the problem is a little bit big, I will make a separate video and send it to you personally and solve your problem. So yeah, I hope this works for you, and happy you turning, I guess. Yeah, thank you for watching, and I have other tutorials as well. Check it out and let me know if you have any other query or any other tutorial that you want me to make. Somewhere you are stuck in your game, let me know. I'll try to find a way about it and let you know, make a tutorial about it. Even this one is a product of that. Someone asked me to make a tutorial about this. So yeah, thank you. Have a great day and hope your games are good.